Have you ever wondered how Netflix recommends shows you might like, or how self-driving cars know when to stop or go? Welcome to the intriguing world of machine learning and deep learning, the powerful technologies behind these and many other everyday marvels. Machine learning and deep learning are subsets of artificial intelligence that enable computers to learn from data and make intelligent decisions. They're the driving force behind a vast array of applications, from personalized recommendations and voice assistants to cutting-edge medical diagnostics and autonomous vehicles. In today's digital age, data is the new oil, and machine learning and deep learning are the engines that transform this oil into valuable insights and predictions. They empower computers to learn from experience, adapt to new inputs, and perform tasks that would normally require human intelligence. These technologies are everywhere. They're in your smartphones, powering your voice assistants and photo filters. They're in your email, filtering out spam and suggesting quick replies. They're in your online shopping, predicting what you might want to buy next. And they're even in your healthcare, aiding doctors in diagnosing diseases and predicting patient outcomes. But what exactly are machine learning and deep learning? How do they work? And how are they changing the world around us? Over the next 15 minutes, we'll delve deep into these questions and more, unraveling the mysteries of these powerful technologies. We'll start by exploring the basics of machine learning, from its key concepts and types to its most common algorithms. Then, we'll dive into the world of deep learning, discussing neural networks and their applications. And finally, we'll look at some real-world applications of machine learning and deep learning, showcasing how these technologies are revolutionizing industries and driving innovation. Whether you're a student, a professional, or just a curious mind, this guide is for you. No prior knowledge is required, just an open mind and a passion for learning. So buckle up and get ready for an exciting journey into the future of technology. Stay tuned as we unlock the mysteries of these powerful technologies. To grasp the concept of machine learning, imagine a baby learning to identify animals. Just as a child observes and learns to differentiate a dog from a cat, machine learning is the method where computers learn from data without explicit programming. Let's break that down. Traditional programming involves instructing a machine to perform a specific task, step by step. It's like giving someone a recipe to follow. But machine learning flips this approach on its head. Instead of telling the machine what to do, we give it the end result and let it figure out the steps to get there. It's like showing someone a cake and asking them to figure out how to bake it. This is achieved using algorithms and statistical models, which are the heart of machine learning. These models learn from the data they're fed and improve their performance over time, similar to how a child becomes better at identifying animals the more examples they see. The magic of machine learning lies in its ability to find patterns and make predictions. For instance, given a dataset of animal photos, a machine learning model can learn to recognize the features that distinguish dogs from cats. Later, when presented with a new photo, it can predict whether the image is of a dog or a cat based on what it has learned. Machine learning is a powerful tool in the arsenal of artificial intelligence. It has been the driving force behind many technological advancements, from self-driving cars and voice assistants to recommendation systems and facial recognition software. These capabilities make machine learning an exciting field that's full of potential. It is changing the way we live, work, and interact with the world. It's creating opportunities for innovation, improving efficiency, and helping us solve complex problems. So just as a child learns to recognize a dog or a cat, machine learning algorithms learn from data to make predictions or decisions. It's an exciting journey of discovery, and we're just getting started. Picture machine learning as a toolbox, each tool designed for a specific task. These tools, or types of machine learning, can be broadly categorized into three main types: supervised learning, unsupervised learning, and reinforcement learning. Let's start with supervised learning, the most common type of machine learning. It's like a teacher-student relationship. Here, the algorithm learns from labeled data, similar to a student learning from a teacher. Imagine a basket full of fruits labeled as apples, bananas, and oranges. A supervised learning algorithm would learn to identify these fruits based on the labels. The algorithm is trained using a set of input-output pairs, and once the training is complete, it can predict the output for new, unseen inputs. Next, we have unsupervised learning, which doesn't rely on labeled data. It's like learning to navigate a new city without a map. The algorithm is left to its own devices to discover and present the interesting structure in the data. For instance, consider a basket full of different fruits without any labels. An unsupervised algorithm would group these fruits based on their similarities such as color, shape, or size. Then there's reinforcement learning, a type of machine learning where an agent learns to make decisions by interacting with its environment. It's like learning to play a video game. The agent receives positive feedback or rewards for correct actions and negative feedback or penalties for incorrect ones. Over time, the agent learns to make decisions that maximize its rewards. For example, a reinforcement learning algorithm could learn to play chess by playing thousands of games and learning from its mistakes. Choosing the right tool or type of machine learning depends on the task at hand and the data available. Whether you're predicting house prices, recommending movies, or teaching a robot to navigate, there's a type of machine learning that's just right for the job. Imagine trying to teach a computer to recognize the face of a friend. Sounds challenging, right? This is where deep learning steps in. As a subset of machine learning, deep learning uses complex structures known as neural networks to learn patterns in large amounts of data. Let's break it down. At the heart of deep learning, we find artificial neural networks. These are composed of layers of nodes or neurons, each processing information and passing it on, much like the neurons in our own brains. These networks can have many layers, hence the term deep learning. But what makes deep learning truly special is its ability to learn complex patterns in data. It's like teaching our computer to find a needle in a haystack of information. This is a significant step up from traditional machine learning models which often struggle with complexity. When we provide a deep learning model with lots of data, let's say images of our friend's face, it gradually learns to recognize the patterns that make up that face. It's not just about picking up simple features like the color of their hair or the shape of their nose. The model can understand more intricate details such as the way their eyes crinkle when they smile. Deep learning models aren't limited to recognizing faces though. They are versatile learners. They can be trained to understand spoken language, to write like Shakespeare, to generate realistic images, and so much more. They are behind many of the AI technologies we use daily, from voice assistants to recommendation systems. So if you've ever wondered how your phone recognizes your voice, or how music streaming services seem to know your taste in music better than you do, now you know. It's all thanks to deep learning. Deep learning allows computers to see and understand the world in ways that were once only possible for humans. It's an exciting field that's pushing the boundaries of what we thought machines could do. And the best part? We're just getting started. Think of a neural network like a virtual brain inside the computer. At its core, a neural network is essentially a series of mathematical equations arranged in a specific structure. This structure is inspired by the human brain and is designed to mimic how our minds process information. The basic building blocks of a neural network are nodes, or neurons, just like in our brains. Each node represents a mathematical operation, receiving inputs, processing these inputs using a specific function, and then producing an output. The inputs to a node are typically the outputs of other nodes, creating a complex web of interconnected computations. These nodes are arranged into layers. The first layer, known as the input layer, receives the raw data. This could be anything from an image, a sound file, a block of text, or any other form of data that we want the neural network to learn from. The final layer, called the output layer, produces the final result of the neural network's computations. Between the input and output layers, we have what are known as hidden layers. These layers perform the bulk of the computational heavy lifting. They transform the input data into a form that can be used by the output layer to make a final prediction or decision. Attached to each node are weights, which determine how much influence each input has on the node's output. These weights are the key to a neural network's ability to learn. During training, the neural network adjusts these weights based on how well it's doing, slowly improving its performance over time. So, in essence, a neural network is a complex system of nodes and weights, arranged in layers, that transforms input data into meaningful outputs. It's a system that learns by adjusting its internal parameters, its weights, based on feedback, making it a powerful tool for learning from data. These virtual brains give computers the ability to learn from experience just like we do. Ever wonder how your email filters out spam, or how your phone's voice assistant understands you? These everyday conveniences are just a couple of examples of machine learning and deep learning at work. These technologies are not confined to the realm of science fiction, but are part of our daily lives, revolutionizing industries and shaping the future. Let's take a peek at some of these real-world applications. Recommendation systems, like those used by online shopping sites and streaming platforms, use machine learning to analyze your preferences and browsing behavior. By learning from this data, they can suggest products or movies that align with your tastes, enhancing your user experience. Similarly, machine learning plays a significant role in financial services. Banks and financial institutions leverage these technologies to detect fraudulent transactions, assess credit risk, and even predict stock market trends. By learning from historical data, these systems can make precise predictions, helping to safeguard our assets and optimize financial decision-making. In the field of healthcare, machine learning and deep learning are making significant strides. They help in the early detection of diseases, analyzing complex medical images, and even predicting patient outcomes. By learning from vast amounts of medical data, these technologies are enabling more accurate diagnoses and personalized treatment plans, thus improving patient care. Moving on to speech recognition, it's a fascinating application of deep learning. Voice assistants like Siri or Alexa rely on this technology to understand and respond to your commands. These systems are trained on thousands of hours of speech data, allowing them to comprehend various accents, speech patterns, and even languages. Last but certainly not least, let's talk about autonomous vehicles. These self-driving cars use a combination of machine and deep learning to navigate through traffic, recognize road signs, and make split-second decisions, paving the way for a safer and more efficient transportation system. From predicting weather to diagnosing diseases, these technologies are transforming our world in incredible ways. The potential applications of machine learning and deep learning are virtually limitless, and we're just scratching the surface of what's possible. As these technologies continue to evolve, who knows what exciting developments the future holds? We've barely scratched the surface of machine learning and deep learning. These technologies have the potential to revolutionize industries, drive innovation, and shape the future. We've covered the basics of machine learning, from its definition and key concepts to its primary types: supervised, unsupervised, and reinforcement learning. Then, we plunged into the deep end with deep learning, uncovering the mysteries of neural networks and their ability to learn complex patterns. We also touched upon the various applications of these technologies, demonstrating their vast potential across numerous fields. From predicting consumer behavior to diagnosing diseases, the possibilities are virtually limitless. But remember, this is just the beginning. As we continue to delve deeper into these technologies, to learn, to explore, to innovate, the horizon only expands. As we continue to explore and innovate, who knows what amazing things we'll discover next?